Yeah, there's one that is that one. I might know.
All right. Any questions? Yes, sir. Take it.
The lab we did on Wednesday is due on Wednesday.
Correct.
Just making sure.
If you'd rather not have them overlap, we can always have labs do the next time you have lab, which means you have 2 days for Monday's labs and 5 days for Wednesday lab. That was not meant to be a threat. It's just a couple of years ago when we first started doing 8-week classes, I asked the class whether they wanted labs to do the next lab period or they wanted a week, in which case there's overlap with labs. And every group I asked always wanted the week, so that at this point I didn't ask anymore. But if you would prefer, so you don't have overlap.
What's the other option?
What we're doing now, where labs are due a week after you do.
All right, that's fine.
So from Wednesday to Monday, you have 2 labs you're working on. Okay, it looked like most people did not have an opinion and just looked at me strangely, but a couple of people said I think indicated they'd rather as we do it now. Okay. Was your question answered?
So the conclusion is that there's a week for each lab.
Yes.
Okay. Yes, they will. Yeah, thank you.
Okay. The exception would be at the end of the semester and if we have a test on Monday or Wednesday. Was there another question?
I'll just ask it after class. It's just about the lab.
Okay, it's up to you. All right, seems like we've gone through the plus minus 0 exercise. We've done test level problems, but I think I know what you're thinking. You're thinking, hey, all that's great, but where's the math? Well, let's do some math. Okay, so let's start working on the definition. So for those who can't read, and I didn't capitalize that first sentence. An object goes from 5 meters per second to negative 10 meters per second in 4 seconds. What is its acceleration?
Negative 3.75 meters per second.
Anyone want to correct that?
I don't even have an answer yet.
All right, let's first deal with the math part. How'd you get negative 3.75?
I subtracted the final speed. Is it velocity or that's just speed? Final speed first minus the initial speed divided by time.
Okay, first off, how do you know that this is not speed?
It's meters per second.
Sorry,
It's meters per second?
no, that's not the issue.
No.
It's negative.
Yes,
Oh, it's velocity.
speed is a positive number. I don't think anyone in here has a speedometer which shows a negative sign. So the negative indicates that this is a, the negative is a direction. I didn't indicate here, if I put a plus sign in front, that's sort of the indication that it is a vector because there's no reason to put the plus sign there. Otherwise, leaving it off, you could make the argument that that's a speed, that's a vector. You could make the, or velocity more specifically, you could make the argument that that speed, potentially you went from -5 meters per second to -10 meters per second, but the intent was that this was my initial velocity. This is my final velocity. All right, so how'd you get -3.75? You did subtracted
Yeah.
the final minus
Versus
the initial?
divided by time.
Why?
Because acceleration is a change in time by change, but it's a change in velocity by change in time.
All right. So -10 minus 5 divided by 4, -15 fourths, -3.75. All right, now let's talk about units. What are the units of the -15?
Meters per second.
So this is meters per second. And what are the units of the 4?
Seconds. So it can, so just meters.
Meter per second squared.
There we go. For those of you who want to cancel out seconds, please refrain. I have meters per second divided by seconds, which is a meter per second times 1/seconds, which is a meter over second squared. What we're claiming is that the velocity changes -3.75 meters per second every second. So this is meters per second, but no more than, should not have more than one fraction bar. And in this particular case, it should not, so -3.75 meters per second squared. So the number should not have more than one fraction bar, the unit should not have more than one fraction bar. And I consider the decimal a fraction bar, in a sense. Don't give me a fraction where the numerator or denominator is a decimal. You could have also answered -15 fourths meters per second squared. You don't have to put it in the decimal form. All right, so why'd you do -10 minus 5 instead of 5 minus -10?
Final minus. It should be final minus initial.
Absolutely. So we can just write this out slightly differently. So this is V final minus V initial divided by time. Now notice I've got a delta t over there and I have just a plain old t here. This is one of those things that delta t would be t final minus t initial. If I set the clock at 0 at as my initial time, so time is 0 when the problem begins, then that's 0. So now I'm just dealing with delta t is equal to whatever the time is minus 0, which is just the time. So that's my rationalization for dropping the delta there. I'm usually really picky about that, but time, or whatever childhood scar there are scars there are. But I have no problem with dropping the delta in front of the t. Multiply both sides by time. And then isolating my final velocity there, I get final velocity is equal to my initial velocity plus acceleration times time. The exact same formula I can write, I think the way the book writes it is just V is equal to VI plus AT. I could also write it as VF is equal to VO plus AT, same equation. So, or I could write it as VF equals VI plus A delta T. All of these mean the exact same thing. This is the way, right, that's the way I tend to write it. I think the book writes it the second way. I can't remember if the book does subscript I or subscript O. Now, you will hear a reference I make to cake formulas. Constant acceleration, kinematic equations. And I guess I'm using equations and formula in there. It is somewhat redundant, but I still call them the cake formulas, or just sometimes more properly just cake. But these are formulas. There are 4 formulas for this that are just darn good to know. We're going to derive them all. But what I have over there is typically the first one derived. And it's all based upon acceleration being change in velocity or change in time. And it does make the assumption that acceleration is constant. So if acceleration is constant. If. Yes, Abigail.
Are we gonna need to memorize all these formulas?
Memorize them, probably not as much as know them.
Okay.
Cool. I think if you panic, first page of any test is going to be the formula page, it's going to be on there. And on a quiz, in-class quiz, it's at the top.
Okay, thank you.
But I do recommend knowing.
Yeah, thank you.
I think it is on the list of the flash knowledge. If not, imagine it is. This dot right here is indicating change over time. This is just shorthand calculus notation because I didn't feel like writing it out. But this in essence is shorthand for saying acceleration is constant. In other words, the acceleration does not change with time, therefore it is constant. If you leave the dot off, then it is not a correct statement. All right. Any questions to hear?
Does that mean overall, we're considering overall acceleration and not instantaneous, or is that different from constant?
If acceleration is constant, then the instantaneous and the average are the same.
Okay.
This technically is average, but I guess I could throw average in there, but for what I want to do next, let's see, let's make it so it works better. An object goes from plus 5 meters per second to negative 10 meters per second in 4 seconds at a uniform acceleration. What's the average velocity?
Negative 2.5 meters per second.
How'd you get that?
It's in between plus 5 and negative 10.
Negative 2.5?
You said negative, didn't you?
Yeah.
Okay. Yep.
Negative 2.5.
The whole thing. I'm pretty sure you said it. You're just leaving it off, leaving someone else to jump in and,
Meter per second.
yeah, don't forget units. Okay, so yes,
Squared.
it is, whoever just said squared, I assume you were just joking. No, it's velocity, meters per second. Or maybe I'm just hearing things. Happened before. Wow. That makes it sound like I'm one of my antipsychotic drugs. I know. Anyway. So let's take a look at that graphically. If I have velocity here, I have time here. The thing's gonna last 4 seconds, so 1, 2, 3, 4 seconds. This is meters per second. And I'm going from 5, so 5, negative 5, negative 10. So I'm here, here. So there's my plot. Acceleration is constant, so as I now state the problem uniform, acceleration is constant, and therefore acceleration, or the slope of this graph is constant. And I'm trying to find an average value. Well, perhaps we just dealt with positives for right now. If this is my initial velocity, and this is my final velocity. Average is defined as a value such that the area of that rectangle would be equal to the area of the actual value under the curve. So my yellow shaded area is equal to this, to the red area. That's how average is defined. There's a formal calculus definition to it, and in essence it boils down to that. All right, so I'm just going to call this V average. So what's the area of this rectangle? How do you find the area of a rectangle?
It's length times width, so it's
Sounded unsure. Say it with great confidence.
length times width,
Okay, what's the length?
velocity initial times time.
I'm looking at the yellow,
Oh, the yellow.
the rectangle.
Average.
Average velocity times time.
All right, so average velocity times time. Good. That's not that. Average velocity times time. All right. What about the trapezoid? How do you find the area of a trapezoid?
It's base times height divided by 2 plus length times width, so it's
Base times height.
divided by 2
2.
plus length times width, because you cut it from with a triangle
Okay.
rectangle.
With you now. All right, so we've got our trapezoid there. We broke it into this. This way is time. This is my initial velocity. This is my final velocity. This is my initial velocity. So what is this?
That is your average.
Delta.
Delta velocity.
Yeah, it's the final minus the initial velocity. That's because if that distance is the initial velocity and that's the final velocity, that's got to be the difference between the two. All right, so we got this distance right here is the final minus the initial. So my area of my trapezoid is VIT plus VF minus VI times T times 1/2. This is the area of my trapezoid. Questions up to here?
Wherever we use that though, wherever we use that equation,
Say it one more
like
time.
in what situation would we use this equation?
We will get to that. I mean, right now I'm just deriving an equation. So the end result is something that we will use for predicting parabolic motion. All right, so I now have this. I am assuming acceleration is constant, thus this line here is a constant. Sorry, it has a constant slope. And if acceleration is constant, I know that VF is equal to VI plus AT. So I can stick that in here. So instead of VF, I can put in VI plus AT. So I've got VIT, sure, so So I have VIT plus V, forgotten already. VIT plus, there we go. VI plus AT minus VI times 1/2 T. That's the area of my trapezoid.
Question.
Yeah.
VIT is just the initial velocity times time, right?
Yeah, that's the, in case in the graph, it's the area of the rectangle.
Right.
So it's VIF plus VI inside the parentheses?
This is VF right here.
Right here.
Oh.
Now the VI's cancel out. I'm left with VIT plus 1/2 AT squared. Can I pause for people to catch up and ask questions?
The little a would be acceleration.
Yes.
Okay.
And that's equal to my average velocity times time.
That's AT squared.
Yes. Now notice it is sloppy notation here. Everything was positive, and when I moved over here, not that column right there, but when I moved over here, everything was positive, so you can sort of get away with not writing the vector symbols, but I'm just doing some little shorthand here. So, if I travel on average 50 miles per hour for 5 hours, how far did I go? 50 miles per hour
250
on average for
miles.
5, sorry?
250 miles.
Yeah, how'd you get that?
50 miles times 5 hours. So 50 times 5.
Yeah. So this right here, my average velocity times my time is, well, if it's average speed times